Okay, welcome back to this video. In this video, we will continue our previous work using Git in order to have various different development lines, timelines, if you want to say this way. But this time we will use it in order to coordinate development between different developers. So if multiple people are working on the same project, we will actually use the same branch and merge strategy as we have before, with the only difference that we will now do them between two various repositories. The typical scenario for that is that if you have a project, a program, a software package which multiple developers are developing simultaneously, and usually you have a so-called upstream version of the project, let's say the official version of the project, the one which everybody refers to if you are talking about that project. It may have one or multiple main developers, and there are all the rest of the people who are just contributors. That means they can read this main repository, but they cannot write this repository. Nevertheless, it's very, very nice and easy in Git to contribute to a certain project. Very important that the parties, so everybody has only access to each other's repository. So basically, if you want to contribute, you don't have to let the developers of the main project to write into your repository, and vice versa. You can contribute without having write access to the main repository. So the typical workflow would be that basically just to here to summarize it, and then we will have a detailed look at that in a sec. That every developer basically keeps his main branch to be in sync with the main branch of the upstream project of the official project, and then every developer is developing the features he or she would like to add in so-called feature branches. Exactly the way we have learned in the previous video, making a branch. And then basically when the developer is ready with the feature, then he asks the upstream developers, so the developers of the official code, or the people who have write access to the official repository, in order to pull in the changes which were implemented in his own repository into the official project. And basically one thing to note is that the main branch of each contributor is basically always representing the upstream main branch. So basically the official main branch of the project, and the contributors never touch that one directly. They only synchronize it with the upstream branch. So let's have a picture for that before we do it indeed with comments. So basically now we have two repositories in contrast to the previous video, an upstream and a contrib repository. Both of them have their main branch. Right, the upstream main is the main developer of the code, and exactly as we have learned in the previous video, also here from the main branch, a feature branch could be created in order to add further commits and then basically implement something. And if the commits are basically, or the feature has been implemented correctly and it's finished, then it can be merged back to the upstream main repository. Right, this is exactly what we have seen in the previous video. Now, what can the contributor do? First of all, the contributor clones the original repository. That means the contributor will have a repository which is a one-to-one copy of the original repository, and with a main branch. And again, this main branch has the same status as the main branch of the upstream repository. Now, if the contributor would like to create a feature, then again, the contributor just creates a branch, exactly as we have seen in the previous video, in its own repository. Let's call it feature 2, and the contributor implements those things here in feature 2. Now, of course, while the contributor is developing, the main repository may progress, right? For example, in the main repository, in the meantime, while the contributor was working on feature 2, another feature was finished and merged to the main branch. But the contributor can always keep track by just synchronizing his main branch with the original main branch by pulling the changes which were made on the main branch of the upstream project to the main project of the own repository, right? And this is a called pull operation. We will have a look at how to do that with Git. Now, when the contributor is finished with his features, he would like to know, of course, that the changes which were made here are transferred to the main branch of the original repository, of the upstream repository. But of course, contributor cannot write. So it will ask the people who can have write access to the upstream repository to pull in the changes which he made. So this is why it's called the so-called pull request. The problem is, of course, that the changes which the developer made in the feature 2 branch might be incompatible with the status of the main, because maybe in the feature 1 branch, which was merged in the meantime to main, there were similar changes made as in feature 2, leading to a conflict. And maybe the people who have write access to the main repository, to the upstream repository, would not like to resolve those conflicts, because they say this is the task of the contributor to resolve the conflicts first, and then only if the changes can pulled in without any conflicts, they will be taken over. So what can contributor do in this case? It's super simple. Contributor has already all the changes which were made on the upstream main branch in its own main branch, because it was pulling it there, and then is merging the main branch into its feature branch. What does it mean? It means that the feature 2, the branch feature 2, contains now all the changes which the contributor did, plus all the changes which were made on the main branch while this development was going on. So basically this thing here, this commit here, contains everything which is on the main branch, plus all the features, all the commits which the feature branch contains. And then there's a pull request, and then people with write access to the upstream repository will just take this one and then this commit and merge it into the main repository, pull it into the main repository's main. And then main, basically here, this commit would basically contain everything from feature 1, because it was already on the main, and everything from feature 2, so both features had been included here. No developer or contributor must, of course, again synchronize its main branch to make sure that it's up to date with the changed main, and this is again a pull operation. Okay, thus it sounds maybe very complicated at the beginning, and therefore we will again make a step-by-step exercise. So we will basically play the role of both developers ourselves. So I have made here two console windows, one for developer 1 and one for developer 2. So whatever is in the upper part of the screen represents developer 1, whatever is in the lower part represents developer 2. So let us start with the following. We have this git demo directory from the previous presentation, and then I will just make directory, let's call it devel1, which represents developer 1. And basically this is, and developer 1 should create a project called hello, and we will just change in this project hello. And then we will, of course, initialize it as a git repository. So we are making a git init. We will, in order so that we can track the status of our repository, we will just start git k in the background, so that we don't have any revisions yet, but that's okay. We don't really commit any changes yet. And of course I will, in order so that we can edit the files here, I will just start Visual Studio Code in this repository, in this repository again. And this is the upper Visual Studio Code. It will represent everything which developer 1 does. Okay, so let's start already to develop here. So let's add a commit here. So we will just create a new file. This new file we will just call it hello.py. Right, we are doing exactly the same exercise which we had in the previous lecture, and this we will just keep it very, very simple. This hello.py should just print hello, the message hello, and otherwise not doing everything. Okay, I have added it. Now I am just going to the console of the terminal of developer 1. Let's have a look. This is we are just adding it, right? Hello.py, and then we are just checking it in as we did before with the message initial check-in, right? So this is basically what we have on the main branch. So this is what we are starting with. This is basically the kickoff of our project. And if you are looking here on the repository graphical view, then we see that we have no Git repository with one single commit which contains the initial check-in. Now this is the point where developer 2 enters. Also developer 2 sees this cool project on the web, or in whichever form, and would like to contribute to that. So basically what will developer 2 do? We will demonstrate that by creating devel2 folder. In the devel2 folder we are just entering it, and this is exactly what developer 2 does, and the first thing developer 2 has to do is to clone the original developer, the original repository. So I will just say git, making git clone, and then we will just clone the repository, which is just in the upper, just one level higher, and hello. So we will just basically clone the hello repository as developer 1. We have direct access to that because it's in the same file system, so it's quite easy. And I will just make also a trick. I will just write the option -devel1. This is the name which we will use in order to refer to this repository, right? Usually if you clone something, the name is first chosen is origin, but here to express more pronounced that this is the repository of developer 1, I will just call it developer devel1. So let's do that. I'm just making a clone. Okay, so and here I'm basically a folder named hello has been created. I'm just going into hello, and this is exactly a Git repository. Again, I can also start code here because we will just develop the code, the project here. This will be here the editor of developer 2, and I also want to start the git k in the background, not git, but git k in the background. And this is exactly the git k of developer 2, and you see that exactly it is a main branch with a single initial check-in, which is the same as the main branch of developer 1. And here there's a remote devel1 main, which means, okay, this is something which resembles the status of a remote repository, which I call devel1, which is just the other repository, and its main status. Okay. So this is the point where we basically created the two branches, two developers, and now let's develop. So let's go back to developer 1, and developer 1, as we already learned in the previous presentation, we would like to implement a feature. And of course, this is a good practice, as we were already discussing, that we are just creating a new branch and switching to this branch, and let's call it, this is the cleanup branch, right? So we are creating and switching to the cleanup branch, and then we are just taking the editor of developer 1, and we are just, as we've discussed already in the previous video, we are just wrapping it into a main function, and we are calling this main function if the name is equal __ main. So this script is executed as a or this Python module is executed as a script, then we will just call main, right? So this is our first commit, and we will just add it to the stage, and we will just check it in and call it wrap script, or make the log message wrap script in main, right? We can also check it whether it had been really checked in. So we are looking at the git k window of developer 1, and yes, we have a new checkup in the branch main cleanup, which is wrapped script in main. We can do the same also like in the previous version, the previous presentation. So we are basically also adding a readme file for that. So we are creating a new file with Ctrl N, then saving it with Ctrl S and calling it, let's say, readme.rst. So I'm creating a structured text file, and I will just here make the project name hello as a chapter header, and just here write trivial demo project, so even shorter than in the previous presentation. Of course, this is not a proper readme, that it should just demonstrate for us how things work out. Again, if I look at git status, I have a file which is not tried to readme.rst, so this is something I have to add it to the repository or the stage first, of course, and then I have it now on the stage, perfect. And now I'm just checking it in, and I will just say, okay, add readme file as commit message. And if you look at here now on the, or if you look up here, what happened in the repository of the upstream project of developer 1, there is the main, and then here I have cleanup and branch with 2 commits. So basically, that's quite nice. And let's assume I was already make the step also to merge it to the main. So I will just switch to main as we learned, and then I will just merge it in the cleanup branch into main. So this is the development which happens in the upstream repository, in the main repository. Let's assume that this project wants you to make only merge commits, so no fast forwards, as we did in the previous video. So I will specify the minus no FF option, and I will just merge in the cleanup branch, right? And then I get the editor with the usual message, which I can just accept, and then I merge it. And if you are looking up here what happened here, then you see that it's very nice. I have here the main branch. There was a side branch with features which had been merged to the main branch. So this is basically how I am now. Okay. In the meantime, developer 2 was also developing a feature. So let's switch to developer 2. Again, let's check whether we are on the main branch. Yes, we are. And now we are also creating here a new branch. Let's call it extend, right? This is our extend branch, and we are switching already to that. And then we will here again edit our code. Yep, here I have the editor for that. So basically we are opening hello.py, right? And then we will just, this is in an original stage, because when we last time synchronized, then the merge, then basically the cleanup branch had not been merged by developer 1 yet. So we are fetching here, so we are in the original state, and we are just extending it by adding the word, and we are just adding it to the stage, and then we are checking it, and the commit message should be extend greeting. If you are looking it up, what happened here, we can just have a look on the git k window, and we see that, okay, we have main, and then with the initial check-in, and then the extend branch with one more commit. Let's make yet another commit just to demonstrate for demonstration purposes. So basically I'm adding then here yet another line, print how you doing, just to be a little bit more polite. And this is exactly what we will do. We will just git add -u, edit, and then commit -m, and then say, let's say, make greeting more polite, something like this. Again, if you look at our git k, then we see that we have main and the extend branch, and the extend branch has two more features, two more commits. Okay. Now we would like our extend branch to be merged into the main of the upstream project, of the original project. So we would ask developer 1 to merge it. However, we know that developer 1 is quite picky, the main developer, and would not accept any merge requests where there are any conflicts. So first we have to make sure that basically our version of the code does not collide with the most recent version of the upstream repository's main branch. So what will we do? We will just switch to the main branch, git switch main, and then we will just I will show that there's a git remote command with which you can basically look up the names which we are using for remote repositories and what they are indeed referring to. Here you see that it refers to level 1 / hello. And then basically what I want to do is now to pull all the changes from developers 1 main branch into my main branch. You remember I said the main branch should never be touched directly for any contributors. It should be always only be used to be synced, to be synchronized with the main branch of the upstream project. So here I will just say git pull --ff only fast forward in this case, because I want to make sure that because fast forward only works if I did not touch the main branch, and this ensures that it gives you an error message if I by accident somehow modify the main branch and it's not an exact copy of the original main branch, ff only, and then from which remote repository, the remote repository which we call devel1, and pull into the main branch where I am now. So basically if you say git status, then you see that we are on the main branch, and then pull in the main branch of developer 1 here. And then you see that something indeed happened. There were some objects and commits imported. And if we are now updating who developer sees the Git project, then you see that you have here all the things which the developer one has on its own. Now the other project, the other branch of developer 2 is not shown, but if we create a new view and make sure that all local branches are allowed, then we can also see that yes, we have here all the information from the original project. The exact main branch looks exactly the same as the main branch of the original project, and additionally we have this extend branch, which apparently does not contain all the changes which happened on the main branch since the branching. This was the last commit. The first commit was the last commit, which was common between the upstream repositories main and our feature branch, and we see that the upstream repositories main has been forwarded. So now we will merge everything from here into our extend branch to make sure that we are up to date and we contain all the changes which had been made on the upstream repository main. So basically the next thing which we would do is we are changing back to the extend branch, to our feature branch, and then we are merging our main branch, which is the exact copy of the main branch of the upstream project. We will just git merge main. And of course, exactly as in the previous video, of course we have conflicts again, because the same lines were basically changed in the two projects. And if you are looking at the editor of developer 2, then we see that exactly here there are two different ways of modifying things, and the incoming change, which is from the upstream project main, had this wrapping, while we had this extension. And the solution is exactly as in the previous video, is to take the extended print commands instead of the print hello, but to put them into the wrapped function, and then of course also in order to remove the various conflict markers. And then because we resolve the conflict, we are just adding git hello p in order to signalize git that we resolve the conflict. You see that okay, modified hello.p plus the new file which was created on the upstream repository added, and then we are just checking it in, and again the editor pops up with the standard message that we are merging main into the extend branch. Now if we are looking now on the history, then you see that basically the extend branch now in our repository contains first of all everything which is contained in the original repository's main, plus merged together with all changes which we made to the project here in our extend branch. So basically this commit here, where we are now, contains our changes plus all the changes which happened on the main branch in the upstream repository while we were developing our feature. So we are quite good now to go. So basically we are ready, and this is the point where we are calling or writing an email or whatever, notify developer 1 to take our extend branch and merge it into the main branch, into its main branch. So developer 1 is made aware of our repository. First, developer 1 will just delete the cleanup repository, which is not needed anymore because the changes are already on main, right? So that we just remove the label here, the branch label. And now, first of all, developer 2 has to tell developer 1 how developer 1 can access the repository, because developer 1 has not seen the developers 2 repository yet. So developer 2 says developer 1, look, you can find my repository in the file system in the devel2 folder. So what would developer 1 do? It would register as a remote repository, add a new remote repository. We will call it this remote repository devel2 because it's the repository of developer 2. And we have to specify the position. This is in the same file system, 2 levels up, and then in the devel2 folder and the hello folder. So we are adding basically the project repository with the .git folder of developer 2, registering it as a remote, and the remote repository. And then you see if you make a git remote -v, then you see the developer under the name devel2, there is a repository here registered, which is this two directories up, and then go to the devel2 folder and into hello. Okay, and then developer 2 lets us know that we want to find that the changes which were made, they are in the extend branch. So we are just fetching the extend branch from developer 2. So from the remote repository devel2, we are fetching the extend branch, and then it has been fetched. So it is also part of our repository. It had not been added to any branches which we have, but we have the commits in our database. And now maybe we would like to investigate what developer 2 really did. So I will just say git switch extend, and then we can just change to the extend branch, and this extend branch is, it also says set up to track devel to extend. So basically this is exactly the same status as the extend branch in developer 2's repositories and repository. And here I can check what developer 2 really did, and if I can just make in the change to my editor, for example, and look it up how developer 2 changed the project. I can check whether I'm satisfied with that or not. Let's assume developer 1 is specific, or the upstream developer is satisfied with the contribution, so decides to merge it into main, and this, the steps are exactly what we already know. We have now a feature branch which is called extend 2, which has the same status as the extend, sorry, which is the same as the extend branch of developer 2. We are switching into the main branch. Developer 1 changes to the main branch and then merges with the usual git merge command without any fast forwarding the extend branch. Right, this is everything local, but it works because we fetched the extend branch of developer 2 already into our database, into our repository. Okay, and then if we make the merge, this time there are no conflicts, so I just an editor pops up and I can already just accept the commit message. And if you are now looking it up how our git key window looks like, then we see that now in the upstream repository, in developer 1's repository, we have on the main is on a commit, which is a combination of the extend branch, and the extend branch is a combination of everything which happened on the main branch in developers 1 repository plus everything which happened in the extend branch of developer 2. And then developer 2 was merging main into its extend branch just to make sure that it's up to date with our main, and then this one we merged back into main. So basically here at this point we have a version which contains all the changes which developer 1 and developer 2 made. And basically with that, developer 2's changes are in the official repository, in the main branch of the official repository. The only thing developer 2 has to do now is to basically just get this main to its own repository to synchronize its main with the main of the upstream project of developer 1's project. So if your developer 2 will get switch to main, and it will again just pull for safety reason, but with minus ff only, devel 1 main. So basically all the changes which developer 1 did on its main branch, and it will just basically get this single commit because this is the only one which we were missing in developers 2 repository. And if we are upgrading here, refreshing the view, then we see that basically now again we reach the status where both projects in both repositories I have exactly the same kind of repository picture. So I have the initial check-in in both, and then all the same commits in both main branches. So basically notice the projects are synced. Developer 1 and developer 2 both have basically the same status of the code, and again both of them can start to branch new feature branches from main and develop new features, and then they can be merged and pulled and fetched exactly the same way again and again. So with that, we have a rough idea how two developers can work on the same project using two repositories. The only thing you have to keep in mind here is that, of course, or a big question which arises is that how a repository can be published. And here at the moment it was super simple. We were just using the same file system. So this is the option which we do. So both developers had access to the same file system. They did not have to write into each other's repository. Read access was enough, but it was in the same file system, so it's quite easy. You can also, of course, upload your repository to the public web server if you want, without any problems. You can even send the entire repository, the .git, basically including the .git sub-repository, to developer 1, and developer 1 can send its repository whenever it's changed, including the .git sub folder, to developer 2. Of course, this is not a very efficient way of doing things, but it's always possible, right? It's also possible to use public repositories, public Git hosting services like GitHub, GitLab, or Bitbucket. They are maybe the three most common which people use nowadays, and they are very, very convenient and and basically the de facto standard how open source project works. But of course, you have to keep in mind that those sites are commercial, and they have definitely commercial interests. So it might be free of charge for you, but of course, there are something which they definitely want, at least your data, for example. GitLab is actually even an open source project, so if you want, you can also run your own GitLab server if you do not like your data to give to third-party companies. In the next video, we will have a look how this repository syncing works if you are using GitHub as a platform to publish your repositories. I will show you that in the next video. And finally, I have a few random Git notes at the end. First of all, the workflow I have shown you here is one of many different arbitrary workflows, right? So Git is super flexible and many different workflows can be realized. The one I have shown you is probably the most common one. But whenever you are basically joining an open source project, have a look. They usually have documentation about their own workflow. For example, the DFDB Plus project, which I am the main developer of, has the DFDB Plus Git workflow document, which tells the people exactly what kind of workflow we would like to use when interacting via Git. And if you are starting your own project, then please try not to invent any new workflows, but use, unless you have very good reasons for that, but it's much better to use already existing and proven one. And for example, you can use the GitHub flow. This is also very well documented on the GitHub site, which is a very common scenario, and most projects use actually this kind of workflow. Okay. Good. Otherwise, I mean, Git guides and GitHub guides, and basically every of the hosting site have very nice guides on Git and how to use their infrastructure to interact with Git. If you want to have a very detailed and very professional book about Git and basically know almost everything about Git, you can just use the Pro Git book, which is free for downloading and contains many different Git commands and ways and tricks how you can work with Git. And finally, just last one remark, we were basically using merging in order to keep track, keep our feature branch up to date with the main project, what happened on the main branch of the original project. We were using merging. We were merging, basically, if you remember, basically we were merging here. We had our side project feature 1, and then we were merging in order to keep up. That was here main, and that was here the feature branch. We were merging in main into the feature branch in order to get the feature branch up to date with the things which happened on main. This is not the only way of doing that. Another thing is, which is very common, is the rebasing the feature branch on main, and I'm not talking about that because it's not that trivial, and it can have some consequences, so you should understand it. But if you want to have a look at that, this is also a workflow, and some projects actually even require that you are always rebasing your feature branch on the main instead of merging main into your feature branch. Then have a look at that. There is a lot of documentation about that, and at this point I think it's only important that you know that something like that as this also exists. Good. And with that, we are finishing with that part, and in the next video I will show you how exactly the same steps must be done if you want to use GitHub as a Git hoster.